Hello. Today we're going to be talking about what density altitude is. This can be a pretty confusing topic for students in the beginning, kind of figuring out what the difference is between pressure altitude and density altitude. But it's actually pretty important to understand what these two are because they affect your aircraft's performance. You'll be able to understand how your aircraft is going to be performing that day, and that can be really good to know for the safety of your flight. So let's move on. I want us to talk about the difference between pressure altitude and density altitude first. In simple terms, pressure altitude is basically what altitude the aircraft thinks it's at. And we figure this out based on only pressure. But okay, let's have a little example here. So I want you to imagine, this is kind of rough, but this is our tower. And just imagine a big column of air, oh boy, acting over top of the tower, okay? So one thing that we do know is all these particles here, the particles that are close to the ground, there's so much gravity acting down on them, and it's going to be higher pressure the closer we are to the ground. So I'm going to do this just to show you that it's higher pressure the closer you are to the ground. Whereas as you go higher, these particles start to space themselves out a little bit. The air up here is a lot less dense, and it's going to be a lot lower pressure. So I want you to remember this because I want to give you an example here. Let's say the elevation of your airport here is 1,050 feet, okay? Let's say your pressure altitude for the day, you have the altimeter setting and everything, and you find that your pressure altitude is 1,500 feet. So what this is telling us basically is your aircraft no longer feels like it's acting closer to the ground, but your aircraft feels like it's taking off from an altitude of 1,500 feet. So it feels like it's taking off from, let's say, somewhere around here. Okay, so the particles are more spread apart, the air is less dense, and I like to think of that as the air is less juicy, let's say. So the particles are not acting on your plane as much as you'd like them to. So we actually want our pressure altitude to be lower. Now, density altitude is basically taking your pressure altitude and you're correcting that for temperature and humidity. Okay, because pressure altitude, we figure this out based on only pressure, based on only the altimeter setting that we are given for that day. That's how we find our pressure altitude. But density altitude is taking that and correcting it for a different temperature or humidity. So I'm going to quickly draw 3 boxes here and we'll move on to how to explain density altitude really quick. Okay, so we have 3 boxes here. Okay, we're going to have one box here that has cold and dry air. And let's say it's a cold winter day out, it's -5 degrees. All of these boxes have equal pressure altitude. I want you to remember that because that's important for this. We're just talking about how the temperature and the humidity is going to affect the density of the air and how that's going to affect our density altitude, okay? So the cold and the dry air. The particles in this box are so densely packed together, as I like to call it. It's very juicy, okay? You want this because they're so densely packed together, there's going to be so much acting on your plane. This is good for our performance because it's going to be a lot better for our plane while it's taking off, while it's flying. It feels like there's a lot more acting on it. So what happens here is this air is going to be very dense, right? And so what this leads us to have is we're going to have a low density altitude in this case. And that's kind of confusing for a second because you're like, okay, well, we have very dense air, so why would we have low density altitude? Well, remember how we spoke about here, the closer you are to the ground, the higher your pressure. So all this is trying to say is it feels like you're taking off or flying from a lower altitude because that's where the particles are so densely packed. And then we have our standard atmosphere box. This one, the air is not too dry, not too moist. As you can see here, the particles are a little less packed together, so it is less dense, but it's also more tightly packed together compared to what we have here, which is the warmer, moist air. So think of this warmer, moist air on a very hot day, okay? It's like 30 degrees out in the summer. The air here, the particles are a lot less dense. They're not as packed together. So again, like I like to think of it, the air is a lot less juicy. So because of that, you're going to have a high density altitude, okay? And sorry if that looks like a P. Okay, you're going to have a high density altitude. So all that's saying is the air particles here are much less densely packed. It feels like you're taking off from a higher altitude because that's where the particles here are less packed, right? So you just need to remember, the higher the temperature, okay, so let's say the higher the temperature, you're going to have lower density. And because you have lower density in the air, you're going to have a higher density altitude. And then with that also comes, if, like for example here, how we had very warm and moist air. So our humidity is a lot higher. Once again, this is going to decrease the density of the air because there's more water vapor in the air. And then this is also going to increase our density altitude. So I wanted us to go over a very quick METAR here, just so that I can show you kind of the difference. So this is our METAR for YKF, and I just want to highlight some of the important stuff here. So here we have our altimeter setting, and remember how we only use that to find pressure altitude. We also have our density altitude showing today. Sometimes when it's just a regular standard atmospheric day, it doesn't really show density altitude, but because temperature and humidity are affecting our aircraft's performance, we have that in the METAR today. So let's quickly go over the difference between finding our pressure altitude and our density altitude here. So to calculate pressure altitude, we take our standard atmospheric pressure, right, which is 299 and we're going to subtract what we have here. So we're going to subtract 2964, and this is going to help us figure out how much we need to correct our altitude by. So what we get from this is 0.3. So our next step here is to do 0.3 times 1,000 so that we could figure out how many feet we're going to correct by. We get 300 feet. And I like to think of it as there's no negative here, so this means that we're going to be adding 300 to our elevation, and CYKF's elevation is 1,054, right? And then if we add 300, that's going to give us 1,354 feet, okay? So what this is telling us here is, okay, we calculated our pressure altitude to be 1,354 feet based on only pressure, okay, based on only the altimeter setting that we were given here. And what is this number telling us? It's telling us that it feels like our aircraft is taking off from a higher altitude. And is that good for us or is that bad? Well, it's not great, right? Because, like I said, you've got less particles, less juicy air acting on your plane. We don't necessarily want that. So that's what this pressure altitude is telling us. But now let's move on to how to calculate density altitude. Okay, so I quickly wrote down the formulas here that we're going to be using. But our first step in figuring out density altitude is determining our standard temperature. Okay, so I've written down what we need here. So 15, and then we need to subtract the pressure altitude that we have. So our pressure altitude is 1354, and then we divide that by 1,000 and multiply by 2. But from this, we get 15 minus 2.7. Okay, so 1354 divided by 1,000 times 2 is 2.7. And our final answer here is 12.3, so that's going to be our standard temperature. Now, finding our density altitude. Okay, we have our pressure altitude, so that's going to be 1354, and now we just need to put our numbers into the formula. So our outside air temperature, we have it right over here, right? It says 12 degrees. So we're going to say 12. And then we calculated our standard temperature to be 12.3. So that's what we have here. Now, if we keep going and we keep calculating what we have in our formula, we're going to get 1354 plus 12 minus 12.3 is, I'll just write it up here really quickly, is 0.3. Sorry, this is going to be a negative 0.3 because 12 minus 12.3 is negative. So we are going to get a negative number here. We're going to get negative 36 when we multiply 120 by 0.3. So our final density altitude is going to be 1,318. So let's talk about what this means really quick. We got for our pressure altitude 1,354 feet, but our density altitude was 1,318. But why? So as we already covered, we calculated pressure altitude using only pressure, right? Whereas density altitude, we adjusted our pressure altitude to correct for the temperature of the air, right? And what do we know about this temperature here? 12 degrees. 12 degrees is less than standard atmospheric temperature because atmospheric temperature is usually 15. So that means the air is colder than it usually is. And what did we talk about before? We learned that the higher the temperature, the lower the density of the air, but we're dealing with a different situation this time. So the air is colder, right? That means that the air temperature is lower. That means that our molecules or particles are more tightly packed together. So our air is going to be more dense. And then because of that, our density altitude is going to be lower. It feels like we're taking off from a lower altitude. This is good. This is what we want because it's helping our aircraft performance. So I hope that all makes sense, kind of the difference between pressure altitude and density altitude. If there's anything you didn't quite fully understand or you'd like me to go over, let me know down in the comments. And if there's any other topics that you would like me to go over, you can let me know about that as well. But yeah, I hope you guys enjoyed the video, and I'll see you in the next one.